Okay, so let's take a look at the answers to this example. Again, this is the discussion board 5 that I posted on Moodle. So for the first example A, do Americans listen to more music comparing to people in United Kingdom? So they select random samples from the United States and the United Kingdom. This is independent data, right? Because you are collecting samples from two different groups. One is from United States, one is from United Kingdoms. So you are not having the same unit or same person doing two different treatments. They are two different groups of people. So this is independent type of data. So because we have separate groups from the UK and US. So for B, does the full moon affect behavior? This is a paired data because the data is collected for the same patients on the full moon days versus other days. So it's the same subject that's being measured on moon days versus other days. So this is typical paired data. So this is paired data because data is collected for the same patient on full moon days versus other days. The next example, potential insurance fraud. This is again a paired data because you are estimating the same cars and you are estimating the same car from Jekyll's garage and another garage. So you are having the same car, but you are estimated on two different garages. This is the same people, I'm sorry, the same cars from two different measurements. So this is, we have estimates on the same cars from two different groups. So this is some case. Here are some examples of how you could distinguish between paired data versus independent data. Again, the first thing you need to do when you see you have two groups of data is to identify whether it's a paired data or independent data. Now, let's then take a look at how you would do inference for the mean of paired data. Because your data is paired, you're having the same unit measuring on two different measurements. So the key idea is we want to see how the measurement on each unit compare to each other, right? So we will focus on the difference between the two measurements on each one of the unit. So the parameter that we are interested in is the mean difference, right? We use the notation mu d to denote it. This is population mean difference. So here, that is the difference that we are focusing on. So this is the population parameter. The corresponding sample statistic is d bar, which is the sample mean difference. So then this is actually very similar to the one population mean procedures that we have talked about. Actually, in many textbooks and also in your textbook, they are not talking about this pair data and there are two inferences of two groups. They are talking about it under the inference for one population, which is actually right, because this is not actually from two populations. It's just you are having two groups of data. That's why I put it here. But many of the textbooks and many of the lectures are putting this pair data along with the one population mean inferences. So anyway, what I'm trying to say is here, what we are really focusing on is the difference of the two measurements for each unit. So we are looking at this mu d. So this will be very similar, as I've mentioned, to the one population inference that we have talked about. The hypothesis test for pair data. First step, establish null and alternative hypothesis. We will have H null equals that is the H null is mu d equals a certain specified value mu 0. Most of the time, we are interested in whether the two measurements from the two groups are different from each other or not. So the most common used null value is 0, right? When this is 0, that indicates no difference on average. So the null hypothesis will be then mu d equals to 0. The alternative hypothesis will take three different forms, as we have mentioned before: greater than 0, less than 0, and not equal to 0. And if you guys still remember, the first two cases are called one-sided test. The last case, which mu d is not equal to 0, is called, what do you guys still remember? The two-sided test. So step 2, check conditions and calculate the test statistic. We will talk about the conditions below later on. So the test statistic is like this. This is actually the same as the test statistic we are seeing in this one population mean. It's just here we are replacing the y bar with the d bar. We are replacing the S for the SD, which is the standard deviation of sample difference. Then the third step identify the null distribution, find the p-value, make decision about the null hypothesis. So the null distribution is the t-distribution with degrees of freedom equals to -1. Remember I mentioned one of the very obvious feature of this pair data is the two groups are going to have the same sample size n, and that is quite reasonable to understand, right? You are actually having the same unit just on two different measurements, so of course they are going to have the same sample size. So the null distribution will be a t-distribution with degrees of freedom equals to the same sample size n minus 1. Then you are going to find the p-value. We have talked about how to find p-value. It's going to be the same. It's found under the null distribution in the direction of alternative hypothesis. Then we make decision about our null hypothesis based on this rule of thumb. If p-value less than or equal to alpha, then we reject H null. Then the step 4 is state conclusion in the context of the alternative hypothesis. Remember, we have mentioned this before. We are never going to say we prove something or we have a proof or we don't prove or whatever. We are saying we provide enough evidence or we couldn't provide enough evidence to support the alternative hypothesis. So this is for the inference for the hypothesis test. For the confidence interval, it's going to be like this. Again, it's actually the same as what we have seen in the one population case. It's just you are replacing this y bar with d bar. You are replacing this s with sd. So here is the confidence interval. So the conditions, I mentioned that we are going to talk about it below. So here is what we're going to talk about it. So in order for this hypothesis test, all confidence intervals to be valid, we have to satisfy two conditions. First, the sample differences must be random. So again, we are talking about the differences here. So it's going to be the same as the one population case. It's just every time you're talking about the sample in the one population case, we are talking about the differences here in this pair data case. The second condition is the population differences. The differences must be normally distributed, or you are going to have a large n. So this is the theoretical step of how we are going to construct the confidence interval for pair data and how we are going to perform the hypothesis test for pair data. Now let's take a look at an example of how we are going to apply the theoretical steps that we have talked about in a real question. Again, I'm going to pause the video here and I'm going to talk about the solutions in the next video. So please work on this problem on your own. We are trying to calculate and interpret a 99% confidence interval for the true mean differences in the average number of disruptive behaviors. And we are also going to conduct a hypothesis test that the dementia patients are more disruptive during full moon at 1% significance level. So there are two things this example is going to do. One is to do the hypothesis test, the other is going to do the confidence interval. So we are going to see the solution in our next video.